All right. All right, so I just copied this over from the practice exam. I'm gonna dim the light in there. As we go through this practice exam, I will give you some ideas of stuff to put on your formula sheet. The exam is Thursday. Homework is due at the beginning of class on Thursday. The test always goes in the order that we cover the material. So we'll start with stuff about fractions and decimals, and then we will do percentages. So that's the way the test will go. So it'll match the order that we cover the material in class. The first question says reduce the fraction to lowest terms. Just wanted to remind you guys about the types of fractions while we're on this problem. What type of fraction would you call part A, 22 over 48? Proper fraction. Part B, what would you call that one? Proper fraction. What if it was flipped? It was 99 over 45. Improper fraction. On number 2, what are those called? Mixed numbers. All right, so let's practice reducing fractions to lowest terms. You can do this in your calculator. You don't have to show work. The advantage of showing work is that I can give you partial credit. So if you show work, I can give you partial credit if something messes up. If you don't show work, there's no partial credit. All right, 22 over 48. What's the number that goes into 22 and 48? 2. So let's divide the top and the bottom by 2. What does that reduce to? 11 over 24. 11 and 24, do those have any common factors? Anything go into both of those? No, so we're done. 45 over 99. What's something that goes into 45 and goes into 99? 9. Right, so that would be 5 over 11. Everybody feel comfortable reducing fractions to lowest terms? Okay. Oh, sorry. All right, so what about converting between mixed numbers and improper fractions? I told y'all for sure that you're going to see one like that on the test. Y'all remember how to do those? Oh, I skipped one. Convert the mixed number to an improper fraction. So I've got 2 here. I just did one that was negative, one that was positive, so we had one of each. Negative 12 and 3/7, and then 1 and 4/5. That's right. 7 times negative 12. What's 7 times negative 12? 80, negative 84? Mm-hmm. All right, so 7 times negative 12 is negative 84. Now what do? Add 3. Negative 81. Now I have everything I need to form my answer. So what is the improper fraction? Good. Negative 81 over 7. All right, y'all try part B. One and 4/5. One and 4/5 is the same as what? 9 over 5, good. So you do 5 times 1 is 5, plus 4 is 9. So that's 9 over the original denominator. That looks like an A, but it's really a 9. I don't like it. All right, what do y'all think about this converting? What about the other way? Do y'all remember how we do that other way? What is the strategy that we use for these improper fractions when we're making them into mixed numbers? Long division, yeah. All right, so 33 over 14, you're gonna do long division. All right, so here's my little long division box. What number goes inside the box? 33. So the top number goes inside the box. The divisor is the denominator. 14 goes into 33 how many times? Twice? That's 28. Yeah. 14 goes into 33 twice. We always do what at this point? Subtract. Alright, so 33 minus 28. 5. We have everything we need now to get the answer. All the pieces are there. So the quotient goes first. That's the number on the top. Alright, so that's going to be 2. That's the big number. Denominator is always going to stay the same, so we know the denominator is going to be 14. So our remainder is the numerator. Okay, last one, 6 over 4. Y'all try that one. Four goes into 6, how many times? Once. What's the remainder? 2. So that's 1 and 2 over 4. We could reduce that, right? I just randomly picked this, so I don't think we've done one like this before where our fraction ended up being something that we could reduce. So I would be fine if you left it as 1 2/4, but it's also the same thing as 1 1/2.
Okay, for say we did it opposite and we did 5/10, would that still be incorrect if it's still the same? If it equals the same thing, if we wrote 5/10, is that still?
Yeah, that's okay.
Go ahead.
Yeah, as long as it's the same thing. Okay. I think that's all of my fraction questions. Or no, I'm sorry, no. I have adding, subtracting, multiplying, dividing. All right, let's do the subtraction one and the division one because that's the harder ones.
Yeah, let's do this.
Again, you can do this on your calculator. The downside is that if you plug it into the calculator wrong and there's no work shown, then I can't give you partial credit.
But you said that showing work is like extra.
Yeah, that's like partial credit. Yeah, so like if you say that you plugged this into your calculator and you accidentally did 19 over 4 minus 1 over 6, so you plugged it in wrong, then I would not be able to give you partial credit. But if you showed your work and you did something wrong, I would give you credit for the steps you got correct. All right, so if you can't see that over there in the corner, this is 19 over 3 minus 1 over 6. This one's actually not too bad. We need to get a common denominator because we're subtracting. If you're adding or subtracting, you gotta have a common denominator. So what should I do here to get a common denominator? Multiply the first fraction by 2. All right, so that is one way you could get a common denominator. If you just multiply the denominators by each other, that would be fine as well. But this is the least common denominator, is to multiply 3 by 2. That's going to make it match the other denominator. But whatever we do to the bottom, we also have to do to the top to keep things equal. All right, so
said we could multiply the denominators to one?
Yes, yeah, you could do like 3 times 6 is 18, you could use that as a common denominator. The disadvantage of doing it that way is that at the very end, you'll have to simplify. So at the very last step, you'll have to reduce that fraction. This way is the least common denominator, and it'll make it to where you are less likely to have to reduce on the last step. So we know that the bottom's gonna be 6. What's the top gonna be? Is that 38? 38 over 6 minus 1 over 6. Right, so once you get the common denominator, the rule is that you perform the operation. If you're adding, go ahead and add the tops. If you're subtracting, go ahead and subtract the tops. But the bottom is gonna stay the same. All right, so we're gonna subtract the tops. 38 minus 1 is 37. Denominator stays the same. And it says here, just reduce the answer to lowest terms. It doesn't tell us that we need to convert it to a mixed number or anything, so we can just leave it here. It wouldn't be wrong to convert it to a mixed number, but you just don't have to. Also, I've left the calculators in my car today, so that's why I don't have the calculators, but I will have them on Thursday for the test.
Hey, question. Do you think we'll be out of here at some point today?
What time is it now?
9:44.
Oh, yeah. Definitely.
I don't have a car right now, so I'm coming, yeah.
Yeah.
I have it, let's just.
The bottom one?
Yeah.
If you can't see it over there, it's 43 divided by 19, or 43 over 19 divided by 2/3. What is the rule for dividing fractions? Keep, change, split.
Why?
Why?
I'm sure I know why, but it's just easier.
That's a great question. I wish I could tell you, but it's actually top secret information. No, I just.
Oh, what you know, yeah, you changed the sign and then.
So you're gonna keep the first fraction, you're gonna change the operation to multiplication, and then you're gonna flip the second fraction.
That's true, you know.
Keep, change, flip. If you're plugging this in the calculator, you wanna just be extra careful. My advice, if you are, especially if you're using a graphing calculator, is put parentheses around the first one and put parentheses around the second one. So if you are gonna plug it in the calculator, especially in a graphing calculator, do this one extra step, put parentheses around each fraction, and that should solve any issues that you might have. Okay, so we're gonna do this by hand. So if you were doing it by hand, you would say, I'm gonna keep that as 43 over 19. I'm gonna change the operation to multiplication. And then I'm gonna flip this fraction to be 3 over 2. Now this is just a multiplication problem. I can perform this normally. So you could even do like part of this by hand, part of it in the calculator, like maybe convert it over into a multiplication problem and then plug it in the calculator. That might make it a little easier.
So you're telling me you keep changing flip and putting the same exact thing if you divide?
All right, so now with multiplication, you're just gonna multiply across the top, multiply across the bottom. All right, so 43 times 3 is 129.
Yes.
19 times 2 is 38. It does want us to reduce to lowest term, so I'm just gonna grab my calculator and see if anything goes into both of those. I feel like it doesn't. So I'm dividing 129 by 2, by 3, by 4, seeing what goes into it. Nothing goes into both of those. 3 goes into 129, but it doesn't go into 38. 2 goes into 38, but not into 129. So we are done with this one. It is in lowest term. And those are the two that I'm going to put on the test. So I'll put a subtraction one and a division one. So those are the two you want to be prepared to see on the test. Okay. I haven't written it yet, but I typically never do more than 15. So 15 maximum. Let's see, because there's 75 minutes, right? Yeah, that's like 5 minutes a piece if I do 15. So I think that's the maximum. All right, I tried to choose some, you know, percentage problems that were, you know, each one was a little different. So we'll just talk about this one because this one's really easy. It says, last week you went by Academy Sports and saw that the pair of shoes you want is $129.99. You got an email today saying that all shoes are currently 15% off. What is the new price? All right, so we know that we're going to subtract something, right? Because the price is supposed to go down. So how do we figure out what is 15%? How do we figure out what is 15% of $129.99? Multiply. Why do we multiply by 0.15?
That's 15%.
Right, that's 15% in decimal form. So you're going to take 0.15 multiplied by 129.99. This is money. Anytime you're dealing with money, you always want to do 2 decimal places. $19.50. Everybody getting $19.50 off? Or, man, I didn't mean to say that. Everybody getting $19.50 here? Is that the new price of the shoes? No. This is how much what? That's how much they're discounted. So you're going to subtract that from the total. All right, so I'll leave that for y'all to finish. So we'll just put a note here. This is not finished. You would have to subtract that off of the total to get the new price. That's what they asked for. What is the new price? All right, so this is the one that I wanted us to do together because this is the one that people seem to struggle with from this section in particular. But if you use that little formula that we came up with in class, which was like percentage times total equals the part, then all you have to do is just plug in what you know and then solve for a variable. So this one is pretty easy if you can remember that formula. So this might be a good formula to put on your formula sheet. And this is just something that we came up with. It's not like anything out of any book. We just made this up. It says, what percent of 640 is 120? What percent of 640 is 120? What number do you think is the total? 6. Yeah, 640 is going to be the total. What do you think 120 is? The part? We don't know the percent. That's what they're asking us. What percent of 640 is 120? So they're asking us to find the percent. I'm just going to call the percentage P. All right, so for the percentage, I'm going to call that P. The total we said was 640. The part was 120. Yep, divide by 640 to get P by itself. Let's see, 120 over 640. I got 0.1875. I'm not done yet. This is in decimal form. So remember, we said that 15% was 0.15. So you move, to go from a percent to a decimal, you had to move the decimal to the left. So we're gonna do the opposite here. We're gonna move the decimal to the right. 2 times, so 1, 2. Round your answer to the nearest hundredth, that means 2 decimal places. So we're gonna keep the 7 and the 5, bless you. All right, we're gonna keep the 7 and the 5 in there. Good. 18.75, and now what am I gonna put at the end? Yeah. If you leave the percent sign off, what am I gonna do? I'm gonna take off part of the point. Because I wanna know that you know that that's a percent. All right, so make sure to get the percentage sign in there. Now, on your formula sheet, you can write down examples. You can write down the little formula that we came up with. You can write down steps for how to do problems. You can write down whatever you want. So I'm telling you that this is gonna be on the test. So maybe you wanna put this problem on your formula sheet. And then you can just, you have an example to follow.
Right, big, are we allowed 2 formula sheets?
No, just one. Yeah, front and back. And some people, prefer to type stuff out and then staple it to the formula sheet. That's okay too, as long as it's, matches the size. All right, so if you, have bad handwriting or whatever, or if you just prefer for it to be typed, you can do that. Oh, sorry. All right, so we went through 2 sections now. We did fractions and decimals, and then we just did the percentage section. This is one more. I wanted to just remind you of how to set this one up because it's been a while since we've done one like this. These numbers are actually work out to be a good answer. So when I first started writing this, my numbers were awful. This one says 70% of all CCGA employees completed the ethics training last month. If 350 people completed the training, how many people does CCGA employ in total? All right, so we know that 70% of all of the employees completed this training. We know that there's 350 people that completed the training. We want to know what is the total. All right, so we're going to use that little formula, percentage times total equals the part. They told us that 70% of the employees completed the training, so we know the percentage. All right, so we know that 70 is the percentage. You're going to have to convert that to decimal form, so don't forget about that. And what about 350? Does that represent the total number of employees or part of the employees? Part, good. So 350 goes in for the part. And we're looking for the total. All right, so we'll call that T for total. All right, so percentage is 70%, but I'm not plugging in 70. What am I plugging in? 0.7, good. We're going to call that T for total times T for total equals 350. Trying to get T by itself. Divide by 0.7. Anytime you divide by a number that's less than 1, it's going to make that number bigger. So don't be alarmed when the number goes up. All right, so what do y'all get for T? 500, good. So divide by 0.7. Cancel. Total number of employees, 500. All right, so that one seems like it's gonna be more difficult, but again, if you just keep referring back to that formula for all of these percentage word problems, these should be relatively easy. All right, so fractions and decimals, percentages. Oh, our next one was rounding and estimation. All right, so I think I told you in class, this is the estimation problem that's going to be on the test. And I also told you that as long as you show me your work, I'm not going to count it wrong. So as long as you can show me your work, I'm going to count this correct. If you don't show any work and you just tell me an answer, I'm not going to give you the credit for it. So you got to show your work. Suppose you went to the mall this morning and you saved your receipts. Use estimation to determine approximately how much you spent at the mall this morning. Show your work. All right, so we've got, you're over there in the corner. The first receipt is $226.89. Second one is $54.73. Then $12.44. And then the last one is $28.12. Now, all of you in this room might estimate this a little bit differently, and that's fine. So some of you might round these up, some of you might round them down. I'm not going to count it wrong based on what you do there. What I'm looking for is, did you estimate it, and then did you add up your estimates correctly? All right, so if I was doing this, I would probably round to like the tens, you know, like 226, I would say that's about 230. But if you wanted to do like, you know, in terms, like in round to the nearest, like 5, like 225, 55, 10, you know, it's all up to you. So I would round this first one to 230. What about 54.73? What would you round that to? 50. 50? So about 50. $12.44. About 10. And then $28.12. About 30. So some of them we rounded them up, some of them we rounded them down. And that's a good, you know, process of estimation. That way you're kind of evening it out with some of them that you rounded down and some of them that you rounded up. All right, so we can add this up pretty easily. 230 plus 50 is 280. Another 10 is 290. Another 30, 320. So you spend about $320 this one. That's all you have to do. All you gotta do is show me how you estimated and then add up your estimates.
Excited for the test.
Me too.
I'm
I'm not
my
excited,
calculus,
because
I'm
then I
excited
have
about
to grade
yours.
them.
I'm mad that he made it seem like we're gonna have to write an essay or something for that class. I hated that, it wasn't even gonna be multiple choice.
This one, I don't think I'm gonna put the tip question on the test, but I did see lots of people struggling with this one on the homework, so I do wanna go over this one with you. It says you're out at a restaurant and you get the bill, it says your total is $53.90. $53.90. You want to leave a 20% tip, but your phone is dead. Use estimation to determine the total tip you should leave. All right, so that's your total. We're going to estimate it to be about how much? About $50. Yeah, then figure out what is 10% of that number. So we would say $53.90, that's about $50. I'm gonna do a 20% tip, but it's easier to figure out what's 10% of something. It's always just gonna be that first digit. All right, so 10% of $50 is $5. So it's always whatever that tens digit is. So what would 20% be? 10. $10. So therefore, 20% would be double that, so that's $10. So it just said, it just wants to know what's the total tip you should leave, so we would say $10. And then you could, you know, if you wanted to take into account that you rounded it down a little bit, maybe you would just bump that up slightly. So if you were doing this in real life. All right, so not gonna be on the test, but I did see lots of people struggling with that one, so I wanted to show you. All right. Sequences. On the homework, which one did we say it was? There's one problem that the sequence is typed incorrectly.
The only reason why is because I put no answer.
Yeah, I know,
I'm
I'm
going
going
to ask her, I was like, this is wrong. I had it.
Oh, there it is, okay. Number 2, it's number 2 on the 1.4 homework. Let's start this over here.
Yeah, this one. And then
So it's the section 1.4 homework, and it's number 2, and it's the first sequence. I don't know what I did, but I typed that incorrectly or had like a mini stroke or something. And that first sequence is not arithmetic or geometric, so just ignore that problem. All right, so just ignore that problem. Number 2, and it's the first sequence. Now, these are all okay. I know the writing is super small, so I'm gonna try to make it to where you can read it. -5, -3, -1, 1, ... Then we have -2, 6, -18, 54, -162, ... Right, so that's the first 2. We'll just do the first 2, and I think we should get one of each. All right, so the first column says, is the sequence arithmetic or geometric? Arithmetic because why?
You're adding or subtracting.
Right, arithmetic is where you add or subtract the same amount each time. So this would be arithmetic. It says state the common difference or the common ratio. If it's arithmetic, you have a common difference. If it's geometric, you have a common ratio. All right, so how much are you going up by every time? Yep, good. So add 2. You don't need to tell me if it's a common difference or a common ratio.
The only one just adding.
And let's predict the next term. 3. All right, the next one, -2, 6, -18, 54, -162. Anytime you see that change in sign, where you're multiplying, or sorry, I said the answer. Anytime you see that change in sign where it's negative, positive, you can guarantee that's going to be geometric. All right, so you must be multiplying by a negative number in order to get that alternating positive and negative. So that must be geometric. Geometric sequences, that's where you multiply or divide by the same amount each time. What are we multiplying by here? -3, good. So multiply by -3. This is exactly how I want you to fill in this table on the test. Predict the next term in the sequence.
Is divided by 2.
Multiply by 2. Or, sorry, what?
Well,
It is.
The next one, yes, the
Oh,
next
I'm
one,
sorry.
yes, sorry.
Doing that.
Yeah, what's the next term in the sequence? 486, positive or negative? Good. All right, we'll leave the other 2 for y'all to do. But there should be one that's geometric, one that's arithmetic. For the next thing. What is, the third row says 24, 12, 6, 3. What's happening there? Geometric, because you divided by 2. Then we have 27, 24, 21, 18. Subtract 3. So that is arithmetic or geometric? Arithmetic, good.
I always believe.
Okay.
I'm like, it's not the same word.
This is our last section. This is problem solving. Y'all said y'all wanted this one on the test, so I put it on the practice test just so we could see it one more time. The sum of 3 consecutive integers is 138. All right, so sum means add. Consecutive means one after the other, so like 5, 6, 7. Integers, that's positive and negative whole numbers, and 0. And they add to 138. All right, what was the quick, fast way I showed you how to do this?
You divide by.
Good.
Remember this.
Divide by 3, because that's how many numbers we want to get in total, 3 answers.
It'll give you the middle one.
You can tell you the middle number, because this is really like the average. The mean. All right, so 138 divided by 3, 46. All right, so there's going to be 3 answers. You just found the middle one.
So you subtract.
Yeah.
45.
45, 46, 47. All right, I hope everybody is going to get that one.
Yes. That's a good question. Somewhere in here.
Oh yeah, this would be, speaking of your formula sheet, this would be a good one to put on your formula sheet, or maybe just write the directions.
That one's for that one.
Magic square.
There wasn't one.
This was a little different. Yeah, I didn't put one on the homework. I thought y'all weren't gonna like it.
I don't know.
Yes, this one's gonna be on the test. It'll be slightly different. This one says complete the magic square. Each of the numbers 2, 3, 4, 5, 6, 7, 8, 9, and 10 can only be used once. All rows, columns, and diagonals must add to 18. All right, so if you can't see this, there's a 4, this is a 10, and that's a 7. All right, so I'm gonna let y'all think about that for a minute. I think this one's a little bit harder, but my advice to you is to start with that biggest number. Yeah, because there's only so many things that can add to 18 if you have to have a 10 in the mix. You could have what, 5 and 3, 2 and 6, 7 and 1. No, 1 can't be in there. All right, so work on that for a second, work with your neighbor, and then whenever y'all think you have it, feel free to go up and fill it in.
No, because the way I did it, you can't do it my way either, because 8, I'm missing 8. I have 8 here, but then I can't do it. Well, 8 can't.
I don't know the answer, so I can't tell you what the answer is.
Oh, so now I figured it. I'm surprised, I really thought that I was gonna struggle.
These are very fancy.
Oh, my,
Alright.
my econ teacher, she, we can't use smartboards at our high school anymore, and my econ teacher, she hates them so much. We have big screens.
Oh, yeah, they have some of those over there in the education building. All right, let's check this. 9, 2, and 7, that adds to 18. 4, 6, and 8, that works. 5, 3, and 10, that works. 7, 8, and 3, that works. 6, 2, and 10, that works. 9, 4, and 5. That works. Everything works. Oh, and the diagonals, I didn't check those. Yeah, they work too. Were y'all able to get that over there? Yeah. All right, so it'll be slightly rearranged from this, but keep that strategy in mind though. Find the biggest number and think about the fact that that isolates or eliminates some of your options for, you know, what adds to the total. So when we looked at that 10, that knocked out a lot of our choices because we knew it had to add to 18. All right, so keep that strategy in mind.
Oh, yeah. I like
This is my dad's worst nightmare on Facebook. Use the clues to solve the equation at the bottom. All right, so you have 3 clues and then the bottom equation. Oh, this one, you have to be careful on this one. Use order of operations. You're supposed to do the multiplication before you do the addition. Don't forget about that. All right, so we've got apple times apple times apple is 27. So what is apple?
9.
9 times 9 times 9?
3.
3, good. Apple is 3.
Oh, more than 1. Yeah, I did more than 1.
All right, so apple is 3, so go ahead and fill that in.
No, I've already missed.
All right, 3 times lemon times lemon times lemon is 24. Oh, I think I know what to do here, but what do y'all think we should do with that 3?
Divided.
Yeah,
That's what I did.
you could divide it over and then you would just have the lemons on one side. So divide by 3, you're really dividing this whole thing by 3. So that cancels, that becomes 8. Sorry, it's so messy. So we've got lemon times lemon times lemon is 8. So what is lemon? Got to be 2, right? 2 times 2 times 2.
I didn't even notice that.
Right, so lemon is 2. Three times 2 times orange is 96. Divide by 6. Orange is 4. Oh, my bad.
This today. No, I was like 16 divided by 2, not 16 divided by this thing. I was like, it's not 4.
All right, so don't forget to do order of operations. Do the multiplication first. What's my answer? 10. Why did I write 6? Sorry. Whew, that was scary. Like my brain was telling me to write 10, but my hand said, never, I got this. If you did not use order of operations, what would you have put there? Yeah. So be careful on one like that. So just pay attention for the one on the test. If you have a combination of addition and multiplication, make sure that you are using the order of operations. Okay, let me end this recording and then we will wrap up.